It is a pleasure to welcome you to today's Policy Engagement Seminar Series. My name is Bernard Ennis. I'm the Director. Ocepp was created by PEO in June 2008 as a means to engage engineers and others in discussions about issues at the nexus of engineering and public policy issues. This policy engagement seminar series is an important part of that mission. These seminars bring legislators, business leaders, and policymakers together with engineering experts to examine important engineering and policy issues. Not only do the seminars offer insight into topical issues from an engineering perspective, they also present a special opportunity for engineers to communicate their expertise to influential audience. And I can say that we're obviously meeting a need because each seminar and conference we've held has attracted a broader, more diverse, and more engaged audience. This seminar in particular has attracted more interest than any others that Ocepp has held in the past. We actually had to create a waiting list for this one and turn people away at the doors today. So something was in the air or water that people find this topic very interesting. Or as somebody said, it was the great name that the seminar was given. The seminar is being recorded via Adobe Connect. A link to that recording will be sent to you by email along with a survey about the seminar. Please feel free to pass this link along to your colleagues. If there's such interest in this topic, we'd like to spread the information around as much as possible. If you're interested in finding out what else Ocepp has done over the years, please check our website. On it, you'll find videos and presentations from our previous conferences and seminars, as well as copies of all the papers published in the Journal of Policy Engagement. That's our insert into Engineering Dimensions, the PEO's magazine, where we publish policy papers by engineers, about 2 or 3 papers every couple of months. So who are today's speakers who created so much interest? Dr. Jennifer Drake is an assistant professor in the Department of Civil Engineering at the University of Toronto and a researcher for the Green Roof Innovation Testing Laboratory and the Center for Resilience of Critical Infrastructure. Her research specialties are hydrology and stormwater management and assessing the impact of low impact development technologies on aquatic environments, urban water security, and wet weather policy. Obviously, she's an expert on how cities can deal more effectively with extreme weather events. For that reason, you may have heard Dr. Drake speak about resilience with Matt Galloway on CBC Radio a few days after the Toronto flooding in early July. Lesley Herstein is a PhD candidate in the Department of Civil Engineering at the University of Toronto. She is investigating the effects of multi-dimensional complexity on the design of engineered water systems in Ontario. With this knowledge, she is exploring new ways of thinking about engineering design and the role of engineers in society to create conditions favorable for the development of more innovative and appropriate water-related engineering design in Ontario and beyond. Lesley is no stranger to Ocepp. She was the winner of Ocepp's student essay competition in 2011, and she recently joined Ocepp's advisory board. Please join me now in welcoming Professor Drake and Lesley Herstein. Thank you.
Right. And it becomes something that is sort of anticipated and expected without due consideration. Like, you should have access to water at little to no cost, and you should have as much water as you choose or desire. Following this, then, we see the recognition or the connection that our secure water supply is only secure if it's clean. And so to address this, we need to have infrastructure systems to remove our wastewater systems. So the next sort of branch of infrastructure is going to be wastewater. And this is generally motivated in response to severe public health events like outbreaks of cholera or typhoid. In our cities, though, when this infrastructure went in, there wasn't a connection between our wastewater and our stormwater. So most of our cities today have a legacy system that is one combined sewer. In the history of our development, when we look back to sort of the 60s or post-war, water infrastructure or natural systems were not really considered of high value. They were just, and often there was a social attitude that this was a dumping ground. Creeks or rivers, they weren't viewed as something that was valued. And so there were a lot of choices that came about because of that social value that was in place. You would hear terms of, we would channelize a creek because it was crooked. So you're correcting someone with scoliosis with a crooked back. A channel or a river was crooked and we would correct it to impose what we thought would be a more optimal solution. Again, though, this has now left us with a legacy of rivers and channel systems that are not necessarily designed optimally and don't have the capacity for what they really need to handle the water that's going to be coming. The next phase, so basically we've gone from water supply, sewer, drains, waterways, and then we start to make the connection between, even if we can take all that stormwater, get it out of the city, dispose it in a civil way, it isn't necessarily clean, and all of that pollution over time has a compounded effect. And this then leads to policy changes motivated to support the recreational activities that we want to have, like beach activities, fishing, and so you see the implementation of things like a phosphate ban or moves in terms of policy to address both point and non-point sources of pollution. And finally, we start to get to a point where in certain areas you have a whole region that has developed to a certain point where we're actually kind of reaching the limits of the natural resources, where we are getting to the point where the supply of water that we need is exceeding the amount that's actually available locally, which then results in the fact that we need to address the source water and the water balance. And finally, the place that we're approaching in many North American communities today is a whole holistic approach, a water-sensitive city. Water-sensitive city, this is an Australian term, but it applies here as well. In North American, we talk about in terms of low-impact design. So, what is resilience? Resilience is a term that has been sort of gaining in interest and popularity and buzz in recent years. And there's a big difference between resilience and sustainability. When we talk about sustainability, we're thinking of systems that are economically and environmentally and socially equitable, not only now, but also for the future. When we use the term resilience, the actual definition of resilience is the act of rebounding, or in other words, to be elastic. So for a community or for an infrastructure system, it's the ability to withstand, cope, manage, and then rapidly recover from a variety of crises. So there's an assumption that we can go from, we can experience a traumatic event and recover easily. It's a challenging term, though, because we need to be careful that we don't subverse it when you're returning to a state of perpetual crises. So we don't want to create communities that are resilient and they can be flooded every year, but they always go back to that pre-state of having a high risk of being flooded. In the context of a community, it's building in things like diversity, flexibility, adaptability, and the ability to change. So we really have three sort of things we can do. We can either choose change, we can reduce our losses, or we can accept our losses. With urban development in a city, we have a lot of inertia, which means there's generally a priority on reducing the losses. It's not that easy to relocate. It's not that easy to, rip up our historical infrastructure. We kind of have to work with what we have and reduce the losses. The problem with this is the solution then is bigger, more, harder. And this, our reduction in losses is only as good as the strength and the maintenance and the investment in the infrastructure. And so we build the dike higher, and the perception is, well, now this area is safe. We've eliminated the risk. The risk is still there. We've just, put that dike. And at the end of the day, the crux of the problem is that system, that protection, is only going to work if we can't maintain it. And in many cases, that is actually not necessarily feasible. So we've got the two, most recent, key points of infrastructure not functioning the way it was designed. We've got the Finch washout, as well as then Don Valley Parkway. Take your pick of the summer events this past year. So this brings me to the economic challenges. I think it's clear to say that we are accepting our losses at a very high cost at the moment. The Canadian insurance industry pays out $1.7 billion in claims annually. Of course, this statistic is completely outdated when we now think of Calgary and Toronto's events this past summer. This is even more powerful when we consider that we do not have overland flow coverage, and so there's a whole other cost that's basically being paid for through emergency relief. We also know that we have an infrastructure deficit. So an estimated $31 billion of infrastructure deficit that's related to water and wastewater. And although the intention is often at the big macro systems, Canada, Toronto, even at local levels, we're also experiencing infrastructure deficit. And I like the biggest example for this would be the maintenance requirements of stormwater management ponds. So swim ponds have been the go-to best management practices for about 30 years. And if you're living in a community that's been developed since the 80s or not, chances are it's been serviced by a pond. These are essentially sedimentation basins that do have a design life that require cleanouts. And the cleanouts are not cheap. They run from $200,000 to $1.5 million. If you consider a community that has 200 ponds with a 20-year lifespan, the number of ponds that once you get past that phase of development that need to be cleaned annually, it's really significant. And it's not, it may not be actually affordable. The last sort of, okay, this has been terrifying, this is, very, very negative. The last sort of, boomerang we've got going at us is climate change. So that we know what's happening now is, the weather patterns that we are experiencing may not be representative in what's going to happen in the future. And so we need to adapt, and we have a few options in terms of adaptation. We can either go back to reduce the losses, let's increase the capacity of our physical infrastructure, or we can start looking at other alternatives. We can make ourselves more flexible. So if the DVP is flooded out, does that really bother you if you have another way to get home? That's another way of addressing or integrating in resilience. And we can start to actually view natural systems as a part of the whole infrastructure package. Finally, I don't know why it's passing, sorry about that. I'm going to talk about some alternative things where we can accept and invest in change so that we're not generating the water in the first place. So hopefully we can have more resiliency. And then the last thing is really any system, it's only going to be effective if it's accepted by the people. And so you need to have an awareness, an understanding of what stormwater is, what weather is, how to deal with it, and an understanding of what to do or how to prepare. So 3 things. We can embrace radical change, we can accept our limitations, or we can also try and start thinking out of the box and designing systems that aren't just doing one thing, but providing an array of services. Sorry about that. So the biggest or a really important change that's taking place in the province right now is a redefining of what stormwater is and accepting the losses or accepting the costs that are required to provide this as a service. And so I have two examples here. The forerunners would be the City of Kitchener, which adopted a stormwater utility in 2011. So basically, based on impervious area, residents now have a stormwater tax. They're now in the process of phasing in their credit program, which is going to then allow property owners who invest in BMPs on their site to receive, up to 45% back in their stormwater utility. Now, Kitchener, it's a substantial city, but it's still fairly small. You can see that this is really changing as a wave with what's happening now in the city of Mississauga. So Mississauga voted in December, just this past winter, 2012, to basically adopt a very similar utility as to Kitchener, where it's going to be based on impervious area and expected to be implemented probably around 2014. Another example is the city of Richmond Hill, which also just this month started a stormwater charge. It's a flat rate, so that they're not doing it quite on impervious area, but it's recognizing that basically the providers of stormwater management and flood protection are conveying now for the first time that this is something that can't be done for free, and we need to have revenue mechanisms to provide the services. The next approach is to choose change. So instead of looking at just end-of-pipe systems, can we do innovative stormwater management at a local level? And this is a project that I worked on last year. It's at the IMAX headquarters in Mississauga. And it's a really good example of how LID should be designed. It's recognizing that we can't adopt a one-size-fits-all policy. We need to come up with systems that fit the unique and specific conditions of where we are. And this okay. The example here, there's a lot of things that were really challenging about this parking lot in terms of trying to integrate it for LID. You'll notice that we have a permeable pavement at the back half, but not at the front. That was because we had a really bizarre bedrock line, and so we only had depth to have the permeable pavement system on one half. But instead of basically going with the conclusion, well, since we can't do the whole thing, there's no point. What we did is we put permeable pavement where it fit, where it was appropriate, and then used a different system, used bioretention systems to treat the water in another area. So we're integrating different technologies and putting them together. The other thing that's most exciting about this site is not only is it an employee parking lot, but it's also a demonstration site, and it's an experimentation site where the University of Guelph is going to be testing the value added by enhancing bioretention systems with pre-treatment or post-treatment technologies. And innovative stormwater does not have to be small. It can go big. It can go for the extreme. A U.S. cellular field in Chicago previously was the largest permeable pavement installation in North America. I believe it has been surpassed by a couple, more than one project in the past year. But it was actually sized for a 100-year storm. So it's on top of silty sand, so good infiltrating soils. And the case for permeable pavement was actually made because of the construction savings that could be achieved. Instead of the cost of the traditional infrastructure, so the catch basins, the manholes, and the pipes, when you recognize the fact that you weren't going to need that same amount, they estimated that they had about $400,000 in savings. So low impact development, it can make economic sense, and it can go big. And this is being recognized not only by individual property owners, but by cities. So our Toronto green roof bylaw is one example, but then also in the US we have both New York and Philadelphia, where they're basically coming out with saying that green infrastructure is a critical part of their 20 or 50-year plan. And the reason they're investing in green infrastructure is because they believe it's going to provide a payback. It's going to reduce the investment that it needs, and it's also going to provide benefits that aren't available from end-of-pipe systems. So a green infrastructure system has additional value through recreational opportunities, property value, energy savings, habitat, a whole number of things. And when we actually recognize the role those things play in an economy, the numbers actually start to add up and make sense. My last closing remark is I want to bring us back to the closing the circle, because I harp on swim ponds all the time. But I think we need to recognize that investment in low-impact development is still kind of using infrastructure to solve our problem. And the infrastructure system is only as good as it's constructed and as it is maintained. And so there really is a huge opportunity here for the engineering profession to move beyond just the construction and design, but to actually be providing all these other levels of service in the long run. And to go back to IMAX here, this was some work that a student that I was working with at University of Guelph gave me. She did the infiltration test just this past summer. So this is the brand new parking lot. How well can it take the water? It's doing fantastic. The lowest one was 800 millimeters per hour infiltration capacity. That's pretty typical. Fantastic. But you can see that already we have areas of higher and lower capacity, even though it's brand new. And this highlights the importance of construction and then maintenance for the usefulness of these systems. When you understand the construction practice, all of a sudden this is going to make a lot more sense. The parking lot was built in a phase. So the permeable pavement went in first, and then the asphalt was laid last. They had guardrails along the side and an entrance on the end. However, the employees didn't like having to drive around. And so they would remove the pylons and just drive over and back and forth. So we had this opportunity of an influx of some construction fines. So you can see that really the implementation, we need we need more experience, and we need more standards and protocols and communications so that we understand the effects of our practices when we're building these things. The other interesting point is this little low infiltration at the back, which when you first see, like, why would that be? And so you pay attention to the habits of the people using the parking lot. And just as people in a classroom will sit in the exact same spot every day, people in a parking lot will go to the exact same spot every day. And there's an employee right at that location who is a smoker. And every morning is, having his morning cigarette and leaving it on the asphalt. So without this communication and education about that this parking lot is not just a parking lot, it's a stormwater system, it's a stormwater infrastructure, if we don't change the behavior, we're really not going to be able to change the impact or the effect at the end. So I think there's a really good opportunity here for a role as engineers to really move beyond just being designers, but also to being educators and service providers. So that wraps me up, and now we're going to talk about more opportunities.
So hopefully everything works out here.
So Dr. Drake talked about some of the projects that are going on, some of the initiatives, sort of one-offs that are happening, stormwater utilities, low-impact development projects across Ontario and beyond. I'm going to talk a bit about how we can sort of leverage these types of projects to make sure that they become opportunities, and so we'll call this part of the presentation extreme opportunities. And I'm going to talk more about how we think about these opportunities and how we think about things, and how our mindset is actually going to make quite a bit of difference in terms of how we move forward in this extreme weather event stormwater realm. Why does it do that? We have to do a few things. So one, Dr. Drake talked about accepting our limitations, embracing radical change, and thinking of triple bottom line design. So I'm going to talk about those three things and how we can seize opportunities in those ways. So the first one is accepting our limitations. And we have a certain number of infrastructure options that we tend to consider. And I think in the past we've tended to go big, and I'll give you a really good example of this. I'm from Winnipeg, so I like to give examples of Winnipeg. The flood of 1950 caused quite a bit of damage, and Manitoba and Winnipeg and the premier at the time basically said, this will not happen again. We will not be flooded to this extent again. As a result, they spent quite a bit of money. I believe it was 63 million in those days, which is about 360 million now. And they basically did bypass surgery on the Red River, which goes through Winnipeg, as you can see here. And they built a little bypass. That's the purple thing. So that's the Red River floodway, if you've ever heard about it. And that was built in the 1960s. So let's move forward to 1997. There's another flood. I recall sandbagging for that flood, but the city was definitely saved, although a lot of the communities outside of the city were not. And the city decided that since that flood actually brought the floodway to its capacity, it would now spend $700 million and bring the system from a 1 in 160-year flood capacity, or the floodway, sorry, to a 1 in 700-year flood capacity, which, I mean, most cities don't have that type of protection. So that's a $700 million investment, okay? Most cities, provinces, jurisdictions cannot do that. That's a lot of money. Flood protection isn't really on a lot of people's radar, although maybe this year it is. You know, Winnipeg has a culture of flooding. There's a lot of other infrastructure that needs updating and investment. There is only so much money to go around, although there is quite a bit of infrastructure money. There's a new 10-year plan at the federal government level, another 10-year plan coming in at the provincial level. So there is money available, but it's being spread out across a lot of different types of infrastructure, and everyone right now is advocating that their infrastructure, specifically transportation, needs to be the one that is invested in. And stormwater has generally taken a backdoor sort of, hasn't really been a huge investment lately. So advocacy on that front hasn't really started. So we need to start thinking a little bit differently about how to stretch our resources a little bit more and how to redefine the limits of the type of infrastructure that we tend to think about when we think of stormwater and extreme weather events, which is the sort of arterial bypass, go large. Maybe there's some ways, and I think we've seen already today, that there are a lot of ways in which we can go a little bit smaller, invest a little bit up front, not too much, but get quite a bit of return on that. And another thing, not only stretching our limits, but maybe even thinking a little bit outside the box, which we tend to say we do, but we don't do often. So just to give you an example of a low impact development project, I can't really say this very well, but it's a project in Mississauga, and it's the Credit Valley Conservation actually partnered with Mississauga to do this project. They did a sort of a neighborhood and a number of driveways put in permeable pavement, and then there were some boulevard cells that they put in as well. There's a lot of savings that go into this. So one of them is that the cost of repaving the road is actually 25% less by doing it this way. There are also a lot of interesting things that happen. So they gave people a choice of whether they wanted their boulevards to be covered in sod or native plant species, and a lot of people chose native plant species. So there's a bit of room for changing the way we think about things. There are people who are sort of pushing on those limits and trying to expand the way we think about stormwater protection. And there are a number of projects that are utilizing this kind of thinking and really sort of breaking the mold on traditional stormwater. Another thing that we have to do, so we have to think about rethink the way in which we think of our limits, but another thing is we need to embrace this idea of radical change. So it's one thing that I often say about water supply, because that's generally where I work, what I do most of my research in is, okay, well, we have these underground systems, and yeah, thinking about tearing them out of the ground is a really crazy notion for a lot of people, especially municipalities. But if I think 1,000 years into the future, are we still going to have those underground centralized systems? Is that something that we want? So at some point, there will be a shift, much as there has been in the past. And the question is, when is that going to happen? Are we going to be ready for it? And will we make the best investments along the way in time, in money, and in a lot of other ways in order to make that change happen? So there has been some progress on that front in the province. I think we are starting to think about how we might produce some radical change, but along the way we're going to have to do some small little changes. One is the Water Opportunities Act. And if you look at the Act, I just sort of took out the first part of it, the purposes and targets. One of the first points there is to foster innovative water, wastewater, and stormwater technologies, services, and practice in the private and public sectors. So that's a start. The province is starting to think about how we can leverage what we have in order to create some sort of innovation front and make Ontario sort of the place to go for water innovation amongst such big names as Israel and some other, and California and some other places. Part 2 of the Act, as you can see below, is the Water Technology Acceleration Project, or now is known as WaterTap. And their slogan is Water Technology Thrives Here. So their actual mandate, they're a nonprofit government organization, their mandate is to make sure that there's innovation in the province on the water front. And they've just started talking about aiming to create a invest to save fund that municipalities, private sector can draw upon, and that would be part of the Ontario long-term infrastructure funding, so it'd be a way to apply for a grant. And the whole idea would be you can invest in these new projects and these new ways and innovative ways of doing things and save in the long run. So instead of spending, $30 million on a new stormwater treatment plant, maybe you can spend $1 million and get the same amount of protection and maybe some more flexibility. So that's what that fund will be for if it ends up being implemented. So they're just working on that now for the new budget. Conservation authorities are an amazing resource. They've been around for a while. They're sort of an Ontario creation. And they've been working on flood protection, flood prevention, as well as emergency preparedness for years. So they are an excellent resource. They do a lot of monitoring. So that's definitely another resource that exists, another piece of the puzzle that will be, in my opinion, that will be very important for any going forward. They're already there. So why not use that resource, that potential, and bring it forward? Making sure that you convey these projects to the public and to other municipalities, to policymakers, very important. So showcasing water innovation is something that came up in 2011 from the Ministry of Environment. So it's just a small program to showcase what was happening in water innovation. We need to do a lot more of that. We need to make a lot of these projects and a lot of these successes and failures available so that people can see that things are being tried and that there are different ways to do things. Maybe there's some collaborations, but there are a lot of people doing a lot of things, and we need some way to bring it to the forefront to get policymakers, to get other types of people in this type of practice to try new things, to say that it's okay and it does work and this is the payback and this is why it's important. So I've talked a little bit about the pieces of the puzzle that exist. I'm now going to talk about how there are opportunities to leverage those pieces of the puzzle, but to even widen the scope of this more so that we don't just hit a wall in terms of innovation and projects. There are a lot of things that are going on, but sometimes these things have a momentum that tends to hit a wall when we talk about scaling to a provincial level, or we even talk about larger projects and believing in more innovative things happening and allowing policy to change to allow for things to happen. This is sort of my standard presentation diagram. I'm going to call it the triple bottom line +2 plus complexity idea. So in the system that I'm going to talk about, there's an ecology to the system. There's an environment that we need to think about, that we need to work within, that determines a lot of the design as engineers that we tend to do. So we like to control it, we like to do things, but there is a point at which the water is coming and we can't do anything about it, or we can do something about it, but we need to just face facts that this is the way the environment is. And we've sort of looked at this command and control idea and it doesn't seem to be working. So working with the environments, which is something that I think the Conservation Authority does very well. Economics is a large factor. So stimulus funding comes in, we spend it on stuff. We don't have stimulus funding, we don't spend it on stuff. We tend to go with the boom and bust of the market as engineers, and there might be some room here for looking at how the economy affects the way that we do our work. Also in this is financing. So there are different ways in which we can leverage different types of financing. There are lots of pension fund money available. It'd be great if we could get a hold of that money. The public-private partnerships seem to be getting a hold of it, so perhaps that's one way that we could find some additional money that could be invested in our province, as well as other types of financing or other types of ways of looking at it, like new stormwater utilities, so different ways, full cost accounting, all these different approaches to government finance. Technology, or the technical side of this system, very important. Obviously in this room we have lots of engineers, and we tend to focus on the technical side of things, but we have a lot of influence. So the things that we've designed in the past are influencing the policies that exist now, and the things that we will design now will influence the policies of the future. So we do have quite a bit of room to play here. People, so talking about that guy smoking a cigarette at the back of the parking lot, socially, we have a lot of work to do in terms of educating people on the fact that, it's not just invisible infrastructure anymore. This is the type of infrastructure that everyone needs to understand. It's not just engineers build it and it works. It's engineers build it and everybody takes care of it and everybody understands it, so that we can, make sure we're investing in it properly and we understand the link between us and that infrastructure. Then we have a number of levels of government, as well as the public service, and I put all of that sort of in the governance realm. So that affects, of course, a lot of the things that we can do, and we need to be aware of that side of the system as well. So we have our ecosystem, our economic, our technical, our social, and our governance dimensions of the system. We need to make sure that we get this right. So we need to make sure that every single piece of this puzzle is on board with whatever we want to do next. And we'll talk about sort of how we decide what we want to do next and how we move forward in this. But everyone needs to be on board, because if you progress in one part of the system, so if we think of amazing technologies and we implement a few of them, but we don't have the policy side, or we don't have the financing side, or we don't have the ecosystem side of it, then we're just going to end up being dragged back into whatever the lowest common denominator is in the system. So we need to really think holistically, especially I think stormwater, because it does affect transportation and it does affect a number of different disciplines and a number of different realms. So one thing that I definitely believe in and talk about a lot is collaboration. And that's sort of how we get all these parts in the system together. We aren't the best at collaborating. It's hard. There are lots of new collaborations that we'll need to think of. But it's definitely an important piece of the puzzle, and I will give you an example of how that can go wrong. There was a Michigan stormwater utility that was approved in 2011 in Jackson City, and they implemented the store. They got it approved, implemented it. There were user fees. They sent out their first bill in April of 2011, and by December of 2011, they were being sued by a number of business people as well as the county of Jackson because they had all claimed that they were charging a tax and not a user fee. And if you want to charge a tax, you need to have a vote. So they were essentially calling this utility illegal because they were illegally charging a tax. And, an approval process for utility is not a simple thing. It takes a lot of time. So now they have to go back and go through all this litigation, which is not easy. So you want everyone on board because, even once everything gets approved and it comes into play, that one stakeholder or those two stakeholders can actually have quite a bit of influence on the functioning of whatever you're choosing to do. One way that collaboration and maybe trying to bring everyone together, because it's not a simple thing to do, as part of my research, I held a workshop about essentially trying to think of how we can think of Ontario's water in the next 50 years. And if you have all these stakeholders in the room, do they have the same vision? And if they don't, then can we create the same vision? So those are actually on your table, and there are enough at the front for everyone. No, I think they're over there now. There's enough for everyone in the room to have one, so you're welcome to take those. But it's this process of trying to get people to think on the same page, trying to get them to think of what the realistic aspects of what could happen and what can happen. Because I think a lot of times we think, oh, if we just did this, this, and this, but that might not be feasible. And everyone's thinking of a different future in their head. So it's important for everyone to be on the same page and to find different ways that are not traditional and different players. If you look at the attendee list at the back of that report, there's some unlikely players. There's a lawyer in there, there's a pension fund manager, lots of people who we haven't invited to the table before. So it's important to bring all those people together, make sure that you're on the same page, and go forward with a strategy for everyone, and that way you get a lot more power in terms of what you want done and a lot more predictability versus a lot of uncertainty with policy and different stakeholders. This kind of makes me laugh. I think when we think of engineers, the last thing we think of is embracing radical change. So I'm going to talk about a few ways in which this can perhaps be done and how maybe we could think a little bit differently about our role. I think we tend to be a little bit passive. We're a lot of times at the end of the line decision making. So how can we integrate ourselves, make sure we're at the front line of this so that we have a lot more certainty in terms of what we're going to be able to do on the front lines. So there are opportunities for us. One is proof of concept. I'm sure there are lots of projects that haven't been showcased that engineering firms have worked on and that engineering researchers have worked on. There's probably a lot of data out there that we don't see, so it'd be great if we could get some more information on how this stormwater alternative world works and who's working on it, and maybe come up with some proof of concept mass data that could possibly be used, and experience as well. Policy engagement, I think that's why we're all here today. There's definitely some room for us to be proactive on this, to maybe get some players together that we don't normally work with, like architects. There are a lot of suppliers that would probably be very interested in this. There are urban planners, so there are lots of professions that I think we could get together with, and really it's not just us working on the policy, it's everyone united front, and if everyone agrees, how can we disagree? Okay, so again, that collaborative aspect and getting connections together that wouldn't normally be together. There are lots of opportunities for new clients. So yeah, if some new stormwater policy comes in and we start designing things, yes, we have new clients, we have new work, but there's definitely opportunity for those new clients. For instance, if you're working on a parking lot for you know, a Walmart or an IMAX, maybe you can show them that there are other opportunities for savings, such as energy savings in their buildings or other types of sustainable infrastructure. So there's definitely room for us to move from the stormwater utility or stormwater realm to different types of infrastructure. So this can sort of be a gateway to changing the way that we relate to our clients in other types of infrastructure that's generally been quite rigid in terms of procurement and who we work with and how we work with them, different types of business models. And I think this is sort of something that's given, but we definitely need to break out of silos. We have to start working with different people. We have to start, you know, getting into the realm of policy, understanding that all of those pieces of the puzzle, the social, the political, everything, it all comes together to affect us. And we affect all of that as well in the long run. So one sort of takeaway point, I think, is that, you know, it's like a portfolio, your investment portfolio. You need to expand and diversify. So we have to, you know, expand the role of the engineer, expand our understanding of the system and how complex it is and how there's a lot of uncertainty, and that maybe we can get through some of that uncertainty and complexity in the way that we do our work. And there's also some expansion for the types of jobs that we can create with this. Definitely room to expand our profession. And diversify, definitely looking at different types of partnerships, different types of business models, and different types of ways of doing things, and getting away perhaps from the traditional bypass surgery way of doing things, big infrastructure, and start looking at how we can create opportunities with smaller, more invest to save type infrastructure. So we'd like to thank you very much for coming today. We'd like to thank the Ontario Centre for Engineering and Public Policy for having us. And I do want to put a shout out to two supervisors who have been very open to this research. One is Professor Barry Adams at the University of Toronto, and the other is Dr. Yves Filion at Queen's University. So we would love to take your questions if you have them.
Please come to the microphone if you, that's the only one microphone. Roger, can you make sure that's turned up? 1, 2, 3, testing. Oh. 1, 2, 3.
Yeah, let's stick it on.
Oh.
You can always come here. They just want.
I think my question is for Dr. Drake. In your example on the IMAX parking lot, you mentioned the effect of parking and traffic patterns on infiltration rates. Could you clarify what mechanism is going on there?
In the IMAX, I was just talking about the effect of construction practices on the infiltration rate. So basically, in this parking lot, it was a phased process. So steps were taken to protect the permeable pavement once it was constructed from material being tracked in, because it was still being used by employees. Because there's, like many construction sites, you know, a limited amount of space. And so even though there were protective barriers, there was still a lack of communication with the employees as to why those barriers were in place. And so they would, you know, on their own accord, remove them so that they would have a more direct route into the parking. So this has led to the, you know, the transportation of some sediment, which is, as I'm inferring, is probably contributing to that differences in infiltration capacity that is present, even though the pavement is so young.
Supplementary?
Yeah.
I think I understand what you're saying. hope this is still on. That the sediment is filling in the permeable nature of the surface, but over its life cycle, isn't it going to fill up with sediment anyway?
Yes.
How do you maintain a high infiltration rate in these extremely good surfaces if they're going to get filled up by mud and dirt and stop working?
Yes. Well, so basically, and this is why maintenance is a really key to these sort of systems functioning. The first thing that needs to be implemented is a monitoring, even if it's just once a year, going out and doing an inspection, or once every few years, and looking for areas that appear to be suffering from clogging. The permeable pavements, it's pretty well documented that traffic loads are going to speed up the clogging process, so your high area traffic areas are probably going to need some sort of attention before maybe the back of the parking lot that no one ever goes to. And for actual maintenance practices, the recommended method would be some kind of surface vacuuming. So when you have a small area, you can do, you do that with small equipment, or I've done work as well as in the US, they've done testing with a vacuum truck where you basically clean the surface and replenish the joint material.
Thanks.
You're welcome.
My name is Ivan Laurent, and I don't have any questions, but I would like to make a few observations. After doing 55 years stormwater management across Canada and overseas. First of all, I think the title of your presentation should be Let It Dream. The reason is that, yes, we engineers, we can engineer virtually anything. And as I'm going across Canada, advising agencies, developers on low impact development, which you mentioned, the problem is that on the one side we have environmentalists or people who are trying to tackle the problem by reducing the runoff. How? Don't pave. Leave as much as possible the area so that it can infiltrate the precipitation. What these people are asking, have narrower streets, don't use paving, which will absolutely reduce the infiltration to zero. We could engineer that. We find that the approval agencies won't accept it. I'm really surprised and shocked that there is not a single representative here from Ministry of Natural Resources or Ministry of Environment, at least looking at the list. We have one representative from the Conservation Authority. You're quite right, they are great resource. But I worked for all 38 authorities, and when I tried to get approval, I would use a different label, not necessarily resource. And the developers are not willing to put in development if they cannot sell the property. They want to put in either single family or other units where low impact development is extremely difficult to achieve because of the standards. I shut up, I have some 30 other observations. Maybe we can read. Thank you.
It's a really great comment. There's a lot of resistance to change, and I'm sure it's very frustrating. I think some of the people who come to me most and talk to me most are actually people who are either retired or ready to retire.
That's me.
Yeah, because it's frustrating, and I think sometimes we say, oh, well, you're the people who are stopping us from doing it, and that's not it. There's a system at play, and it determines everything, all the decisions that are made and everything that we do, and if we do not recognize the way that the system works and how to push different levers in that system, we're never
reduce the impact of flooding, like for example, recent flooding in Toronto? I'm involved in this, including MOEs. They don't get allowed storage for flood storage or quantity control storage. So I was wondering, what would you think? How is there going to be a significant impact on flood reduction by investing on LRTs? Could you please comment?
Well, and that's why I wanted to use the U.S. Cellular field, because it's up here. We aren't really using LID for big extreme events. It's water quality focused, and that's not necessarily, at least in my experience, that's not the conditions south of the border of us, that they are using LID for extreme weather management. Obviously, there's sort of a regionality. An extreme weather event in Texas is not going to be what an extreme weather event is going to be here. But in areas of high development, like the Greater Toronto Area, where we're really reaching the limits of growth, and all we have in terms of options is redevelopment and retrofit. It seems to me that we have to look to the local to find ways to increase our capacity. And this is something that I am really interested in and want to actually look at, is how, if you have a number of these small systems, but many of them, how do those all work together to actually, providing a significant impact in terms of capturing water and the capacity and addressing those sort of peak flow events. We're only approaching that point here, I think, in Ontario now, where we're starting to actually see communities in some areas, or small, residential neighborhoods that are being designed dominated by LID systems. So it's a really exciting place, and it's almost a Wild West kind of situation we're in right now, where really we can try anything once or twice, and we have a lot of chances here to really see how far we can push this technology to provide these services. One of my other research areas is working with green roofs, and this is something that I'm really passionate about and hoping to address, is that we have the green roof bylaw, and that's great, and they're starting to go in, but the designs of green roof systems are not really being optimized for stormwater management. And I think we have a lot of opportunities by, increasing customizing the designs, expanding the products, and actually coming up with systems that are going to, not only are they, giving us these energy benefits and green and healthy and pretty, but they actually are, contributing to peak flow reduction, or capturing the water, or allowing reuse, so that we can reduce the volumes.
Max from PEO. In terms of trying to address, I think, the paradigm shift of moving from drain to let it rain, it's sort of the model, the way that I think the insurance industry is looking at this in terms of how they've been paying out, what the incentives are, et cetera. What seems missing here for me is the data that compares these two approaches in terms of that, so that you can motivate the insurance industry to embrace this and to say, what, if we look to a permeable systems approach, as opposed to draining it away as quickly as possible, we'll avoid the floodings of basements and things like this. So we have to have the data so that they can understand, appreciate those things, to be able to move that forward. And I can appreciate all the emphasis on large-scale infrastructure, but something to think about perhaps is on the small scale, individual homeowners. The Canadian homeowners are, I think, far more environmentally sensitive and able to act than governments. If you look at energy conservation, federal grants and credits and things like this that people have embraced for energy conservation, something perhaps could be parroted from that to look at these systems. But what can be done for for the individual homeowners, for small units, in terms of retrofitting their local environments, either for some kind of a cistern, home cistern kind of approach, or certain permeable backyards and other things. But we have to get the insurance industry to embrace that to help move that along.
I 100% agree, and I think particularly your comment about cisterns and gray water, we haven't really talked about that too much today, but that's, I mean, that's an area that ultimately that really should be a part of our you know, suite of solutions is, you know, reusing water, and it's probably the most challenging out of all of the sort of options to actually integrate because of the policies and all of the legislation that would be affected by that. But I agree.
One small historical comment is that a lot of the infrastructure, specifically water supply infrastructure that we have, is a product of not people. Well, a lot of times people say it's because of illness and whatever, which is true. There was a lot of illness at that time in the late 1800s, early 1900s, but there were a lot of fires, and the insurers are one of the groups that actually spearheaded the creation of all these water supply systems so that they wouldn't have to deal with all of the fire insurance outfall from these massive fires that would catch along the entire city. So there's definitely room for unlikely players in the game.
Before Bernie closes the question and answer session, I thought I'll ask my 2 cents worth. Santosh Gupta, I'm counselor at the Professional Intelligence here. You talked about the Water Opportunity Act. What's the status? Is it already in force, or it is in the offing? And how is it being embraced by the regulatory agencies, particularly the ministries? The ministries we talked about.
Okay. It's just starting. It's getting started. So, for example, WaterTap took a year and a half or 2 years to get itself started. It's also more of a blanket act. So it creates a reason for other, sort of a platform for other types of policy that supports the Water Opportunities Act. But there's it's definitely just getting started, so it's in an infancy phase. But it was, I've heard at least, it was a big job to get everyone on board with that act. So I think people are wanting to make sure that it's a useful one, I guess, and a significant one, yeah.
All right, I'd like to thank you all for your questions, and I'd like to thank Dr. Drake and Lesley Herstein for this interesting presentation. I just have one comment to make, and I graduated from engineering many years ago, and I don't know, something's changed in engineering over the last 30 years. I didn't hear this kind of talk from engineers when I graduated. I'm glad to see it. I think engineers have, over the last 30, 40 years, changed the way they think about things. I'm glad to see it, and I hope we continue to do that. And I look forward to participation of people from this group and Lesley and Jennifer in our future endeavors here. So thank you very much for coming, and thank our 2 speakers. And we have a token of our appreciation.
Thank you.
Thank you very much.
Thank you.